Supplemental math videos from Circle Christian School. Welcome to the world of perpendicular and angle bisectors. This is where we cut things in half. It might be a segment, it might be an angle, but whatever is getting cut in half leaves us with a very special point of congruency, a guy sitting inside the triangle, that when you draw lines to either the sides or the angles or they're perpendicular, they all have very special properties. Let's first talk about the perpendicular bisector. A perpendicular bisector cuts the sides in half at perpendicularly, of course. Let me find my pen. Found it. Okay, what that means is that each one of the sides of the triangle are cut in half, so therefore they're congruent. So we are basically using a midpoint to find that perpendicular line. And because it's perpendicular, it means it's just 90 degrees. Now, because this triangle is a bit equilateral, that from the point of congruency, the guy in the middle here, the lines that are important here, that are equidistant, are the lines that are going to the angles. So if you follow the little red dotted line here, they're the special ones. They're all going to be equidistant. That means they are congruent. And they're going from the center. What you have to watch out for when you start matching the math up is you are left somewhat with a whole bunch of right triangles. And with right triangles, you're going to have to remember that Pythagoras comes out, Mr. A squared plus B squared equals C squared. Very good. Now, because we have these lines that go to circumcenter, this is where we can actually circumscribe. That means to put around a circle. Probably not the best circle, but you get the idea. The triangle sits inside the circle. Maybe that's a little bit better there. Okay. So the thing is, the perpendicular lines give us special equidistance lines from the circumcenter. Triangles with angle bisectors, those are lines that cut the angles at the vertices in half, so they're congruent. Leave us with a very special point of congruency inside called an incenter. From the incenter, now we're going to make perpendicular lines. It's kind of the opposite of the ones that we had with the perpendicular bisectors. Notice the perpendicular bisector started with N from the center, went to the angle. With these, they come from the angle and then make a perpendicular line to the sides. So it's got a backwards quality to it. And the special thing that's happening are these perpendicular lines coming off the angle. Coming off the center there, the incenter. And all these guys are the same size too. And again, because there are right triangles being made, you have to kind of watch out for Pythagoras again, and there's some A squared plus B squared equals C squared again. And with this one, you can inscribe, okay, a circle goes inside. There we go. There's a circle. All right, let's go over our geometry strategies. This is where the geometry meets the algebra. Hello. And our whole focus here is to take whatever properties are happening in the geometry and use it within, it's going to dictate how we set up our algebra problems. Remember, in geometry, things are either congruent or they all add up to equal something. So the first thing you're going to do is remember to always draw a picture. Draw, draw, draw. After that, take a look at what you've been given. Let me white that out because I don't really want to F just yet. What you've been given and what you have to find. It's really hard to solve something when you don't know where you're going. Label everything. Label the givens and label the hidden things that have happened. If you have some midpoint, you know you've got congruent segments. You might have mid-segments coming from the midpoints. So label the given and label the hidden things. Now you're going to make all your geometry discoveries. What kind of properties are happening with the lines? At this point, mid-segments we know have half of the opposite side. So geometry discoveries. Perpendicular bisector. We know that we have a circumcenter and lines that go to angle bisectors from the in-center, lines that go to the side perpendicularly, because now you're going to be able to set up the algebra. And solve the problem. And again, remember that in geometry, things are either congruent or they add up to something. And when you're all done, make sure that you go back and answer the question. Because finding X is one thing, but if the question is how big is the angle or how big is the side, there's two parts that are happening inside here. All right, go make a friend with a geometry shape.